Welcome to Chapter 5, Access Controls. We'll cover the roles of access controls in an IT infrastructure. Um, Talk about some of the access control concepts and technologies, some of our formal models, how identity is managed by access control, and developing and maintaining system access controls. So what are access controls? There are methods used to restrict and allow access to certain items. For example, our automobiles, homes, cars, and even cell phones, and our computers. Your first experience with access controls might have been when you locked a sibling out of your room or used a combination lock to secure your valuables at the gym. You purchase your first car, the keys fit only your car, so only you can unlock your lock and start your car. So just as lock and key systems on your house and car are access controls, so are the personal identification numbers or PINs that you use at your bank account and credit cards. Uh, there's four parts of access controls, right? So identification, who's wanting access, authentication. Once you've got their identified, who let's verify their identity, right? Authorization, what can they do, and then accountability, logs, monitoring, etc. And then you can break these down into two phases, um, policy definition phase and policy enforcement phase. So the definition, is just creating it, who can access, what systems and resources can they use. You're defining it, who can use what and how. And then the enforcement phase is, identification, identifying the user, authenticating the user, and then authorizing the user, right, based on the definition phase, right? So, but the identification and authentication, who are they, and are they authenticated, and then monitoring phase, the accountability phase. We have two types of access controls, physical and logical, right? So physical are buildings, parking lots, physical assets, right? Physical devices. Logical could be, websites or network device, or applications, logical controls. Some physical access controls can be smart cards, use these cards to get in and out of the building, or your badge, badges, things like that. Those could be physical access controls. Keys, also physical access controls. Logicals, decide which user can get in a system. They're monitoring what each user does, restraining or influence a user's behavior on the system. The book talks about a security kernel, enforces access controls for computer systems. But there's a central point of access controls, and what's the reference monitor concept, right? So the reference monitor concept is here. The subject or user requests access to an object. The kernel intercepts this request, and then the kernel refers to its rule base, and also known as the kernel database. Its access control list, and it uses these rules to determine the access rights. And access rights are set according to the policies of an organization. And then the kernel allows or denies the access based on the defined access rules. And then all access requests handled by the system are then logged for later for tracking and auditing. We have four central components of access control. We have users, resources, actions, and relationships, right? So users, or as the book tries to call them, subjects, are people who use the system. Resources are the objects that we're trying to protect in the system, and they can be accessed only by authorized subjects. in authorized ways. And then actions define the ways that you can utilize the activities that the authorized users can perform on the resources. And then relationships might be optional conditions that exist between users and resources. And some logical access control solutions. So biometrics, could be static biometrics, your fingerprint, your eyes, your facial features, your hand geometry. These are static. They're not changing. They're not. They are just who you are. But you have dynamic. The voice inflections. They're unique to you. But the keyboard strokes are unique to you. Signature motions are unique to you, but they're fluid. They're moving, right? It's a process of moving. Or tokens can be synchronous or asynchronous. Passwords are typical user passwords, but you have add-on features as requiring stringent or complex passwords. Being locked out if somebody failed attempts at logging in, and then auditing the login, whether it was successful or failed. And then you can have single sign-on, where you sign in once, but you have access to multiple systems. You don't have to re-sign in. And a lot of times this uses Kerberos. It doesn't have to, but Kerberos is a very popular process to use with single sign-on. Authorization policies. You have authorization, you have group membership policies, and authority level policies. So authorization, users are assigned privileges. Right? Group memberships, the groups are assigned privileges, and users are then put in groups. And that's the best model for most user access. Is you don't grant users access, you grant groups access, or roles of groups, and then you put the users in the roles of groups. And then authority level policies can be used. Methods and guidelines for identification. Some methods, username, smart card biometrics. Guidelines are the actions, and the counting or the logging, auditing. Authentication types, knowledge, something you know. Ownership, something you have. Characteristics, something unique to you, such as your fingerprints. Location, somewhere you are. Actions, something you do and how you do it. So the way you type on a keyboard could be an action. So examples of authentication by knowledge, right? Passwords, passphrases. Try not to use a weak password because they can be susceptible to brute force dictionary attacks. Use password best practices. Usually there'll be account lockout policies tied to how many failed attempts before the account gets locked out, so that to help avoid a brute force dictionary attack. And then you audit the logon events, either successful or failed. You log both because you might need to know when someone logged in and did a change and who it was. And even though they may have the right to do it, you may just need to find out who did it. So logging successful logins is also a good idea. Authentication by ownership, right? So you have synchronous or asynchronous tokens. There's just various different types of tokens. And here's an example of an asynchronous token challenge response, right? The user sends its user ID and request for access. The server sends a challenge. The user then enters the challenge number within the smartphone calculates the response or the password. You send that password to the authentication server, and then the server grants you access. So then authentication by characteristics or biometrics, so static, right, what you are, like your fingerprint. Dynamic is what you do. It could be your voice, it could be your typing cadence. Some concerns around biometrics, right? Sometimes they're not very accurate, and at least the early versions weren't. They're getting better. Um, uh, Reaction time and acceptability, right? So acceptability, they may or may not be legally bound, or compliant. And then what do you do with the data? Do you store that biometric data? Somebody's fingerprints or voice print, um, and how do you handle that? Those are all some concerns. And here's various types of biometrics. But right, like I said, there's privacy issues. Biometric technologies don't just involve collecting data about a person. It collects information that is intrinsic to a person. Every person must submit to an examination, and the examination must be digitally recorded and stored. Unauthorized access to the data could lead to misuse, right? Because it proves, because with that data, somebody can impersonate you at a whole new level. And then, of course, you can have authentication by location or action, where you are or what you do, right? Recording typing patterns. And then we have single sign-on, which is a very nice feature to add for users. They only have to sign in once and get access to multiple applications, so it reduces human error. But it is very difficult to put in place and get working across all the applications. Once again, in many instances, a single sign-on will utilize Kerberos and LDAP. Microsoft uses both of these in its Active Directory, but it's just one of many possible solutions, even with just Kerberos and LDAP. Policies and procedures for accountability, right? So we're logging files, monitoring files, what's retention on the files, how do we dispose of them, and then are there any compliance requirements as far as how long we have to keep them or purge them, right? There may be laws that you have to purge them at a certain time, or more likely is that you have to keep them for 27 years, right? There are some out there like that, or longer. Formal models of access control, discretionary access control, DAC, mandatory access control, MAC, non-discretionary access control, and rule-based access controls. The first one, discretionary access control, means of restricting access to objects based on the identity of the user and or groups to which they belong. The controls are discretionary in the sense that a user with a certain access permission is capable of passing that permission on to any other user, right? Then mandatory access controls, they determine the level of restriction by how sensitive the resource is. Think classification labels like top secret, secret, right? And the system owner makes the decision to allow access. And MAC is stronger than DAC. Non-discretionary access controls are closely managed by security administrators, not the system owner or the user, right? So discretionary access controls, the user had control. The MAC, it was the DAC was the user, MAC is the system owner, and the non-discretionary access control is a system administrator or security administrator. And sensitive files are write protected for integrity and readable only by authorized users, and it's more secure than discretionary access controls, and ensures the system security is enforced and tamper-proof. Rule-based access, or explicit rules, access is allowed or denied to resource objects based off a set of rules defined by a system administrator. And here you see Jane, Fred, and Albert have access to the customer service application and the accounting application. But the rules say that only Jane and Fred have access to the inventory application, but it's based on some rules that are defined. Access control lists for Linux and OS X, right? So file permissions are based on read, write, or execute. You know, those are the three permissions, and they get applied to owners, groups, and global users, right? So every file has a owner, right? And that owner has read, write, or execute for that file. Each file has groups that have access, or a group that has access to the file, and it has read, write, or execute. And then the next is every file has the global users or anyone else, and then they have read, write, or execute. So it's very limited, but it does work on how it is. But you have to be in one of those three groups, and within those or three attributes, either the file owner, a group that owns the file, or a group that has access to the file, or the global users. If you don't fall into the owner or the group, you fall in the global users. And then those each have either read, write, or execute. So there's only 9 permissions. There's 9 permissions on every file in a Linux or Mac machine. Read, write, execute, read, write, execute, and read, write, execute. So that's how the permissions are controlled, and access is controlled on Linux and OS X. Now Windows, it has a lot more granularity, and you have users and groups that have access to formulate your access, but you should really only be giving access to groups, not users. You really should. It's best practice. But there's also shared permissions if you're accessing the file remotely, and then security permissions if you're accessing the file remotely and or locally. So the security permissions always apply. The share permissions only apply if you're accessing the file remotely. And so share permissions have full, change, read, or deny. And then the actual local security permissions on the files are full, modify, list folder contents, read, execute, read, write, special, and deny. So there's a lot more granularity on Windows for the file permissions. And here's just a typical access control list for 3 users, giving you the access that they have for each of the directories or printer. And here's role-based access. So role-based access is a lot like group access, but you define a role and you create a role and you grant it access and permissions to do certain things. So here they've got a customer service agent role. It has access to 3 applications, and then if you put the users in the role, then they have access to the applications. This is really, really great and convenient for management. You know, just whoever's in that role has access to those apps, and then if you remove someone from that role, then they no longer have access to the apps. It's great for onboarding if you're doing role-based, you know. But you can do that with groups just as easy. But it is a good way to do it, is role-based access. Content-dependent access, you know, based on the value in data, right? I.e., your department, right? So the local manager can only see the employees in the same department, whereas the human resources manager can see all employees' data, you know, based on the data value assigned to them, right? So the content depends on what they can see. Constraining user interfaces, right? So that we have different ways to prevent access in general, right? So you may have different menus, right? So you may not even see the payroll menu if you're not in payroll, right? If you have no reason to go to payroll, you shouldn't see it in the drop-down menu, right? Or you could have different database views the same way. You're restricting the view, what data you get to see, as well as the user interfaces. Maybe it doesn't have certain buttons, right? Because you don't have access, don't need access. And then we can encrypt certain aspects. I'm not sure how this is tied with the user interface, but definitely you can encrypt data so they can't be seen. But you could mask. I guess you could mask data. So like Social Security numbers, maybe you only see the last four instead of the full Social Security number. That's not really encryption, but I'm not sure where the book's going with encryption on user interface, because you don't have encryption on user interfaces. Here are several access control models, and they have certain models that you can deal with. Here's the Brewer and Nash integrity model, right? So the bank auditor, based on certain rules, he's got a conflict of interest with the Bank of Norwich, so he doesn't get assigned to those cases or those audits. Whereas he can do the Bank of Gloucestershire, and you can see their information and everything and do an audit on their files because he doesn't have a conflict of interest. And then, so effects of breaches and access controls, right? So private information, data loss, right? Or corruption of data. So the first one is you actually lose the data, it gets out in the public, it's no longer private. Second one is we have our data, but it's corrupt, it's damaged, right? So we can also lose some of our business intelligence. You could, access into the facilities, right? There could be danger to the facility staff and systems, damage to our equipment, failure of systems and business processes, right? These are certain threats or examples of threats that can happen, right? So gaining physical access, exploiting hardware, software, electronic eavesdropping, intercepting communications, getting access to our networks, or exploiting our applications. These are all threats to our access controls. And then effects of a violation of the access controls. So somebody gets around or circumvents our access controls, right? So loss of customer confidence, loss of business opportunities. You might get new regulations imposed on the organizations. Definitely could have some bad publicity if you've lost your data. And more oversight from laws and regulations. Financial penalties. Credentials and permissions management, right? So systems that provide the ability to collect, manage, and use information associated with access controls, right? So just the management of our access controls. Microsoft offers group policy and group policy objects to help manage access controls. It is a wonderful feature within Microsoft. You can push out thousands and thousands of different security access controls and security policies out to machines and servers, and instantly secure thousands of machines with a new security access control and put it in place. It is a really, really great feature that Microsoft does offer. Centralized and decentralized access controls, right? So AAA, authentication, authorization, and accounting. You'll see Radius used a lot. It's one of the most popular. It's an older style. It came out really, with dial-up and all that, but it's still in function and used today. A lot of times you'll see it used in your wireless access for most organizations. TACX Plus is a IETF standard. It's newer than Radius, but it does the AAA authentication. Diameter is a base protocol and extension. SAML, open standard based on XML. It is great for authentication and authorization, and you'll see a lot of organizations use SAML for their authentication and authorization, and a lot of times, especially cross organizations, where you have one organization that needs access to resources in another, you'll see SAML used a lot in that instance. Decentralized access control. So now we don't have a way to really centralize or organize or manage it, right? We have the access in the hands of the people, right? So PAP and CHAP, they're very old protocols and used dial-up and things like that. They're still around. But then OAuth is a fairly new, and yes, mobile devices, but also social media companies and that, if you're ever doing any of the programming and the application programming interfaces, APIs for any of the social media or new applications out there, you'll use OAuth a lot, especially the HMAC, the HOTP, the HMAC-based one-time password. You'll use that a lot in API access calls. And then you got the time-based one-time password, TOTP, and that's a lot of times where you have to enter in a number or whatever, right, one time to log in and authenticate. Privacy, right? So we need to communicate expectations for privacy or lack thereof, and then acceptable use policies and login banners are places where you would discuss and describe what privacy the users can expect, right? And then, but we could have monitoring in place, that invalidates your privacy, right? So opening up mail or email, checking of phone logs, checking logs of websites visited, right? Collecting information through point of sale terminals or even closed circuit TV or video, right? So cloud computing is the practice of using computing services that are delivered over a network. The computing services may be located within the organization's network, a private cloud, or provided by servers that belong to some other network, third party or public cloud. And then there's several hybrid or different, right? Community cloud is shared by several organizations, two or more organizations stand up and share a cloud, or a hybrid cloud where you have some of your resources that are private in your own private cloud, and then the others are in the public cloud. Examples are, you might keep your physical data and database servers on your company's premise, right, in your company's data center, in your private cloud, but you put the web servers, the front end, in the public cloud, maybe at Amazon or Microsoft or Google, right? So those are three big cloud providers, third-party public cloud providers. And there are several advantages and disadvantages of cloud computing. Most of the advantages include some cost savings, right? There's no need to maintain a data center, no need to maintain a disaster recovery site. You can outsource the responsibilities, and you can get on-demand provisioning. You only need pay for what you need at that moment, and you don't have to worry about having excess servers sitting idle waiting for demand. You just spin up new servers when the demand is there and shut them down when it's not. But disadvantages are private, keeping your data secure, right? There's much greater damage of losing data or private data leakage, especially if you're on a public cloud where your equipment and your applications are on servers with other businesses' applications and servers. And so there's a risk of losing data and not being as secure. And then, of course, if you have everything in the cloud, you have to have internet access, or your workers don't have access to the applications they need, right? So if you lose internet access and all your stuff is in the cloud, even if your stuff is running, you don't have access, right? And then you need to trust your outside vendor, whoever's hosting your cloud. You need to trust them, and you need to make sure your contracts are written and negotiated, because whatever's in your contract is all that they're going to do. And then, for example, what happens when you cease using that cloud vendor and want to go to another cloud vendor, how is your data handled? Is it deleted? How's it deleted? Who owns the data? All that needs to be worked out before you start using the cloud. But once you have it all worked out and you know what you're dealing with, then it's fine, as long as you can prepare and plan for it. But you need to make sure you know what's in your contract. That is the end of Chapter 5, Access Controls.